The distance between 2 points. How do you find the distance between 2 points? I'll draw a picture again. And let's see, we have these 2 points. This is point 1, so that's the x value of point 1. This is the y value of point 1. This is point 2, the x value of point 2, the y value of point 2. And I want to find the distance between them. If you take a measuring tape, you measure from here to there. What is that distance? Does anyone remember Pythagorean's theorem?
Yes.
C squared equals what? A squared plus B squared. Remember that one? When you have a right triangle? So this distance here, from here to there, is x sub 2 minus x sub 1. It's the difference between these two x values. This distance here is the difference between these two y values. It's this distance minus that. Now, Pythagorean theorem says if I call this side C, this is A, this is B. C squared equals what? A squared plus B squared. That's Pythagorean's theorem. And if you want to find C, what do? Don't you take the square root of both sides? So C, which is the square root of what? A squared plus B squared. I'm not really calling C, I'm calling D the distance. So the distance, that's what C is the square root. What is A? A is this distance, which is what? X sub 2 minus x sub 1 squared. And B is that distance, which is what? Y sub 2 minus y sub 1 squared. And that's the equation you see in our book. Don't be surprised if you see y written first and x second, or x written first and y second. Doesn't matter. But that's how you find the distance between 2 points. We'll take baseball, for example. Baseball. Well, you got home plate, you got first base, second base, third base. It's really a square if you connect it. It just, instead of sitting, that's what it looks like this. That's what the diamond looks like. But if you take that and turn it like this, it looks like a square if you do it flat. You know? So if this distance is 90 feet, this distance is 90 feet, and you want to find that distance. That's a 90-degree angle here. You want to find that distance between them. We used to use Pythagorean's theorem, right? You go, well, that distance here, C squared equals A squared plus B squared. 90 squared plus 90 squared. 8100 C squared equals what? 16,200. C C equals the square root of 16,200. I didn't have to use that equation. And if I have a calculator there, $16,200, take the square root of that. 127 and what? 127 point what? 28. Looks messy here. But a lot of times you don't have a picture like this. Like, you can't see that triangle, it's not really clear. And it doesn't have to be a right triangle. I mean, we're going to make it. You're not given what I meant to say. You're not given a right triangle. You're just given 2 points. And they want to find the distance between them. Like this one. Find the distance between 3.2 comma 5.7, I'll use decimal intentionally, and 6.4 comma 2.9. You have 2 points, you want to find the distance between them. Doesn't matter if I use decimal values or not. I get 2 points. That's x1, y1, x2, y2. So notice I don't have a triangle here. I don't see a triangle. I can make one. I don't need to make one. I can say the distance between any 2 points is given by x2 minus x1 squared plus y2 minus y1 squared. What's x sub 2 here? 6.4 minus what's x sub 1? 3.2 squared plus y sub 2, which is 2.9, minus y sub 1, which is 5.7 squared. (6.4) minus 3.2 is what? Is that 3.2 squared? That's going to be a negative number. That's a 2.8, negative 2.8 squared. Now again, when you write negative 2.8, you better put them in parentheses. Watch why. If you write negative 2.8, can you see it on the screen? And you see a square of that. Is your answer going to be positive or negative? The calculator will give me a negative number. It's supposed to be positive. Notice it gave me a negative number. Why? Because the calculator will square the number only and leave the minus sign. Does not square the minus sign. If you want to square the whole thing, you better write that in parentheses. Negative 2.8, close parentheses. Now square that. That should be a plus. So add to it 3.2 squared. So that's the square root of what? 18.08, which is 4.25. That's the distance between them. 4.25 units. So find the answer to this, find the answer to that. After you square them, add them, you end up with that number, take the square root, that's it. That's the distance between any 2 points. Again, you can go and make a triangle and find A and B and do Pythagorean theorem. There's no need for it. I did that here on purpose because I don't have the points. I don't know what the coordinates are. I don't know where that point is in relation to this one. I don't know where that point in relation to this. I'm trying to find it. So I use Pythagorean theorem there. Here I have a straight line. I'm looking for the distance between the 2 points. Who cares? You know what the shape looks like. I don't have to make that right triangle. I can do that using that equation. The distance. We said the slope in the other video, which is the follow-up video because I screwed up. We said the slope is defined as what? Rise over the run. Again, quickly here. Maybe we'll add some trig to this. Make you think about it. Because you love trig. Remember, if you make a triangle out of these two, this is x1 here. This is y1. This is x2, y2. If you make a triangle out of this, isn't this x sub 2 minus x sub 1? And that's what? Y sub 2 minus y sub 1 again. So what's my slope? The rise over the run, which is what? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now I want you to put your thinking cap on. Go back to trig. If I call this angle theta, what is tangent theta? Sine over cosine is true, but in terms of sides, Sebastian, what two sides? Opposite over adjacent. What's your opposite here? Y sub 2 minus y sub 1. What's your adjacent? Minus what? Hey, wait a minute. Isn't this equal to m? So guess what? Your slope is actually tangent theta. That's what the slope is. So if you want to bring the trig back, that's what m equals to. Anyone who didn't cover trig watching this video going, what the hell are you talking about tangent theta? You know, what's a tangent? But that's in trig. It's the ratio of the opposite side to the adjacent side. That's what a tangent is. So which is the same as the slope. So if you know the angle, you really know the slope. Just take the tangent of that. If you know the slope, you can find the angle. Inverse tangent. A couple more things in this section, and we're done. And we already discussed them. Again, in the following video, or the next one, we talked about them. And that is parallel lines. I'll just do them again. So I'll have a section for each topic, or a video for each section. What's a parallel line? What do we know about them? Sebastian told me parallel lines what? They never intersect. The distance between them always the same. Absolutely correct. Then I said to him, I wasn't talking about the distance between them. I was thinking about the slope. So if one line is like this, then the other one is going to be like that. Those are parallel lines. They have the same what? Same slope. They have the same slope. So if line 1 is parallel, that's how we write parallel, that's a shortcut. 2 slashes. To line 2, if they are parallel, and if M1 equals 5, what do you think M2 is going to equal? Better equal to 5. If M1 equals 1/3, what's M2? 1/3, they have the same slope. If M1 equals negative 2/5, then M2 will be what? Negative 2/5. They have the same slope. So parallel lines have the same slope. And the last statement I'm going to make is perpendicular lines. And again, we discussed that one, but we'll bring it again. Again, we said perpendicular lines, that means they cross at what? At 90 degrees. So the slopes can't be the same. You'll see from my picture in a second. Here's one line. And there's the other line. This is line 1. This is line 2. If you look at line 1, has positive slope. And if you look at line 2, it should have what? Negative slope. How can they be the same? They can't. Negative slope. But we found out if you take the slope of the first line and you multiply it by the slope of the second line, the result is always a negative 1. Or slope 2 equals what? Negative 1 over slope 1. As I said earlier tonight, I said all you got to do, flip and change the sign. Flip and change the sign. If line 1 is perpendicular to line 2, that's how we write them. If M1 equals 2/3, what is M2 equal to? The second slope. Flip and change the sign. Negative 3/2. If line 1 has a slope of negative 2/7, line 2 will have a slope of what? Switch or flip and change the sign. 7/2. If line 1 has a slope of 7, that's 7/1. Line 2, flip and change the sign, which is what? 1/7. Yes, flip and change the sign. Negative 1/7. Thank you. And there's more on the next video since I screwed up, because we cover this in detail, more detail than this video on the next one. So I'll stop here.